Hello and welcome back to Dr. Logic awkwardly does logic in her kitchen. Today I want to talk to you about variables. They are one of the new things that we've added in predicate logic that distinguishes it from propositional logic, and they play a very important role. They are what allow us to express universal statements, to express statements of existence and individual being. They are what give propositional or predicate logic the expressive power that they have. So we're actually going to spend probably a couple of videos talking about variables first from their syntactic roles. So how do I identify variables? How do we calculate what variables are occurring in a particular sentence? What is the difference between a variable and the occurrence of a variable? Free variables, bound variables, occurrences of these, the difference between a formula and a sentence, which is not a distinction that we have yet had. All of these are things that have to do with the ways that variables function in syntactic strings in a predicate language. So the very first thing that I'm going to tell you is just how to identify the variables in your sentence or in your formula, because I told you there was a distinction between formulas and sentences. This is about formulas. Now, given our convention that we will generally use like x's and y's and z's, and also a different typesetting for variables than we do constants, pretty much you can look at a formula and you can tell which things are the variables and which are not. However, I'm going to pretend that you aren't clever and aren't able to just look at things and see them, but rather you are much more like a computer who needs to be told in explicit detail what things are variables and what are not. So I'm going to give you a definition, which may seem like a sort of silly definition because you already understand how to identify variables, but that's left over from last time. Just bear with me and pretend that you are a computer who doesn't understand anything. So this is the definition of basically how to spot variables. And this is going to be a recursive definition on the basis of terms. So we build our complex formulas out of terms, but the variables themselves only ever get into the formulas via the terms that they occur in. So it's going to be a recursive definition because our definition of term was recursive. You recall that we had kind of the two base cases, variables and constants, and then we had the complex cases where we applied functions to other things that were already identified as terms. So for every term tau in some quantified language LQ, the set, which we will call var tau, so var standing for variables, is defined as follows. So it will depend on what type of term tau is, what variables it has in it. So, I should say this set var t is the set of variables occurring in tau. There you go. So there's three cases. If tau is some constant c, then, well, what variables are in a constant? None. So var of c is the empty set when c is a constant. If tau is a variable x, well, what variables are going to be in the set of variables occurring in this term? Var of x is just going to be the set containing x. So the base cases are easy. Constants do not contain variables. Variables are variables. And so the set of variables in a variable is the set containing that variable. It becomes more interesting with the functions. So if, actually, no, I'm not going to do it var. I'm not going to do it as an if. I'm going to do something else. If we have, say, some function that is applied to terms tau1 to tau n, the set of variables in this term is going to just be the union of all of the variables that occur in each of the tau 1 to tau n. So the variables of tau 1 union with the variables of all of the other taus up to tau n. So recall, union just is the dumping everything into the same bucket operation in set theory. So it's all the variables in tau 1, all the variables in tau 2, all the variables in tau 3, etc., until you reach all of the terms that you have. So as I said, if I'm writing out some, if I say x plus 2 equals y, or wait, I'm not going to do that because that's actually a formula, not a term. Let's stick with terms. Let's say x plus 2 or y, or x plus y times 3. So these are things that I could form in a predicate language that has functions for multiplication and addition. In this case, it's really easy to just kind of look at things and say, okay, that's a variable. That is supposed to be the number 2, not the letter z. It's a constant. That's a variable. That's a variable. That's a variable. That's a constant. So very easy to just kind of look at it and see, but sometimes you want to be able to state explicitly how you can determine what the set of variables in a particular term is, and this is how you do it. So there you have it. Next time we will talk about how these variables occur in broader formulas, so not just in terms, where we will want to make a distinction between formulas that, or variables that occur freely and variables that are bound. So that will be the next distinction that we need to make. Until then, take care and see you later. Cheers.